Hello friends, welcome to lecture series on essential mathematics for machine learning. So, in the last lecture we have seen that if a random variable is given to you, its PMF or PDF is given to you, that how can you find expectation or variance of that x. So, we have seen in that lecture that if we want to find out expectation of x, then this is nothing but summation x of x when x is discrete and it is integral from minus infinity to plus infinity x f x dx when x is continuous. And variance of x is simply expectation of x square minus expectation of x whole square. So, now in this lecture we will see that what are the some of the important distribution functions, mainly Gaussian distribution or normal distribution, which is used in machine learning, and how can you find out mean or variance of those distribution functions. So, first distribution function is basically we will use, that is binomial distribution function, discrete case. So, before going to binomial distribution, what do you mean by Bernoulli's trials? So, a series of trials are referred to as Bernoulli's trials if the following assumptions hold. So, what are those assumptions? Number 1, there are only two possible outcomes for each trial, either success or failure. So, if we are doing some experiment, okay, and there are only two possibilities, either pass or fail, either success or failure. So, that is the first assumption for Bernoulli's trial. The second assumption is the probability of success remains same for each trial, it will not change. Okay. Next is the outcomes from different trials are independent. Okay. The first trial will not affect the other trial, the second trial will not affect the third trial, and so on. And there are finitely many such trials conducted. It is not infinite, this is finitely many. So, if these four assumptions hold, then the series of trials which we are conducting are called Bernoulli's trials. Now let us come to binomial distribution. What do you mean by binomial distribution? So, if n independent Bernoulli's trials are performed, then the random variable x denoting the number of successes in the n trials is said to follow the binomial distribution denoted by x, b and p. This is a notation where p is the probability of success in each trial. Here p is the probability of success in each trial and denotes the number of trials, total number of trials. If there are x successes in n trials, then we have n minus x failure, of course, because if out of n trials we are having x success, that means remaining trials are failures, and that means n minus x are failure. So, the probability of x success will be given by, see, the probability of x success, now out of n there are x success. So, it is NCX. NCX is simply factorial n upon factorial x into n minus x, factorial n minus x, multiplied by Px, which is the probability of success of getting x trials, x success, and this is 1 minus p is a failure, and there are n minus x failures. So, power is n minus x, and of course, x is varying from 0 to n, meaning when x is 0, that means all are failures. When x equal to 1, that means 1 success, x equal to 2, that means 2 success, and when x equal to n, similarly that means n success, all success. So, this distribution is basically called binomial distribution. Now, of course, if you see this particular distribution, which is f x equals to p x equal to x, which is given by n c x p raised to power x or q raised to power n minus x, where q is nothing but 1 minus p and x is varying from 0 to n. So, if you see this distribution, of course, for any x between, if for any x from 0 to n, it is always non-negative. So, first condition is that f x is always greater than or equal to 0 for all x, that is of course satisfied. Now, if you see a sum of all f x for x, so if you calculate this, so it should be 1 if it is a distribution function. So, let us see. So, it is n c x p raised to power x q raised to power n minus x, and x is varying from 0 to n. So, it is nothing but p plus q whole raised to power n, okay, as per the binomial theorem, and p plus q is 1. So, 1 raised to power n is 1. So, how can we find out? So, for a discrete case it is a PMF, how we can find out expectation of this random variable x, and how we can find out variance. Okay. So, if you want to find out expectation of x, expectation of random variable x, so that will be summation x f x, x is varying from 0 to n. So, this is nothing but summation x from 0 to n. So, this is x, this is n c x p raised to power x q raised to power n minus x. So, let us try to compute this value. So, let us expand this p plus q whole raised to power n. This is nothing but summation x varying from 0 to n. This is n c x, this is p raised to power x q raised to power n minus x. Okay. Now, let us differentiate both sides with respect to x. So, differentiate both sides, both the sides with respect to x. So, what we get? We get both set to p, sorry, with respect to p. So, it is n p plus q raised to power n minus 1, it is summation x varying from 0 to n. So, it is x n c x p raised to power x minus 1 q raised to power n minus x. Okay. Now, we want this value x n c x p raised to power x we need, q raised to power n minus x. So, you multiply both sides by p. If you multiply both sides by p, so it will be n p into p plus q whole raised to power n minus 1 plus summation is equal to summation x from 0 to n x n c x p raised to power x q raised to power n minus x. So, this is nothing but expectation of x, and that this value is nothing but because p plus q is 1. So, it is nothing but n p. So, this implies expectation of x is n p. We can say that mean of binomial distribution is n p, where n are the total number of trials and p is the probability of one success. Okay. Probability of success in probability of success basically p. Okay. Now, if you want to compute variance of x, so how can we compute variance of binomial distribution? Okay. So, variance will be given by, we know that it is expectation of x square minus expectation of x whole square. So, this we know that it is n p. So, we have to compute this. So, expectation of x square as per the definition, it is summation x from 0 to n x square into n c x p raised to power x q raised to power n minus x. Okay. It is sorry, it is x square. Okay. So, we want to find out this value. So, again what is p plus q raised to power n, as we have already seen, it is summation x from 0 to n, it is n c x p raised to power x q raised to power n minus x. You differentiate both sides with respect to p. So, it is n p plus q whole raised to power n minus 1 summation x varying from 0 to n, it is x n c x p raised to power x minus 1 q raised to power n minus x. Now, you want x square here, okay, for this. So, if you want x square here, so first you have to make it p raised to power x. So, you multiply both sides by p. Okay. If you multiply both sides by p, so it is p raised to power x q raised to power n minus x. Now, again you differentiate with respect to x because you want x square. So, again you differentiate with respect to x. So, that is nothing but n times. So, first as it is derivative of second will come here plus second as it is derivative of first will come here, and that is nothing but summation x varying from 0 to n, it is x square n c x p raised to power x minus 2 into q raised to power x minus 1, sorry, it is and q raised to power n minus x. Now, as p plus q is 1, so p plus q is 1, so it is n, it is np minus p plus 1 is equal to this value. Okay. Now, for this again you want to compute this. So, for this you again multiply both sides by p. So, you multiply both sides by p. So, what is expectation of x square finally you will get? This you get as np into np plus 1 minus p. Now, what will be variance of x now finally? Variance of x will be expectation of x square minus expectation of x whole square. So, that will be n square p square plus n p into 1 minus p minus n square p square. So, this cancels out. So, it is n p q or n p into 1 minus p. So, that is how we can compute mean and variance of this random variable. Okay. So, let us discuss this example. So, this example is based on binomial distribution. The probability that a new building violates the building code is 1 by 4. What is the probability that a building inspector who randomly selects 4 of the new buildings for inspection will catch none of the buildings that violate the code? So, what is n? First identify n. What is n? Number of new buildings are 4. What is the probability of success? Here success is violating the code and that probability is 1 by 4. So, that means 1 by 4. So, what is q? Q is 1 minus p, that means 3 by 4, not violating the code. We want that none of the building, none of the none that out of all these 4, the inspector will catch none of the building that violate the code. That means for x equal to 0 we have to find. So, that means x equal to 0 and that is nothing but 4 c 0. From here you can get it is 0 and that means 3 by 4 is to power 4. So, that means 81 upon 16 into 16, that is 256. So, it is 18 upon 256. Okay. So, in this way we can find out. Now, the next distribution is Poisson distribution. So, let us suppose a random variable x is follow a Poisson distribution which is denoted by p lambda. This is here parameter is only one, which is lambda. In the binomial distribution we are having 2 parameters n and p. Here we are having only lambda and its PMF is given by lambda raised to power x e raised to minus lambda upon factorial x and x is varying from 0 to infinity. Okay, lambda is greater than 0. So, one can easily verify that it is a PMF because this is greater than equal to 0 for every x, number 1, and if you take the summation over entire x from x is varying from 0 to infinity, then this sum comes out to be 1, that is easy to verify. Now, if you want to find out the mean or variance of this random variable x which is following Poisson distribution, so how can you find? So, let us see. So, what is the PMF of this? This is lambda raised to power x e raised to power minus x upon factorial x. X is from 0, 1, 2 and so on. So, what is expectation of x? Here it is summation x p x. Okay. So, what is the PMF of this? It is okay, lambda raised to power x e raised to minus lambda. Okay, fine. So, it is here it is e raised to power minus lambda. Okay. So, it is x from 0 to infinity. So, it is summation x from 0 to infinity, it is x lambda raised to power x e raised to power minus lambda upon factorial x. So, that will be summation. So, it is lambda raised to power x e raised to power minus lambda upon factorial x minus 1. Of course, when x is from 1 to infinity now, because for 0 it is obviously 0. Now, you can take one lambda common. So, it is x from 1 to infinity, again it is it is e raised to power minus lambda. Okay. So, it is lambda raised to power x minus 1 upon factorial x minus 1, and it is e raised to power minus lambda. So, this e raised to power minus lambda will come out because it is free from x. So, it is lambda e raised to power minus lambda, and when x is 1 it is 0 upon 0, lambda raised to power 0 upon factorial 0. So, we can write x from 0 to infinity lambda raised to power x upon factorial x, and this value is nothing but e raised to power lambda. So, it is lambda into e raised to power minus lambda into e raised to power lambda, which is lambda. So, we can say that mean of random variable following Poisson distribution is lambda. So, now if you want to find out its variance, so its variance will be expectation of x square minus expectation of x whole square, as we already seen. Now, what is expectation of x square for this? This is summation x from 0 to infinity x square into lambda raised to power x e raised to power minus lambda upon factorial x. So, this is x from 0 to infinity. Now, this can be written as x into x minus 1 plus x upon factorial x into lambda raised to power x into e raised to power minus lambda, which is x from 0 to infinity 1 upon factorial x minus 2 plus 1 upon factorial x minus 1 into lambda raised to power x e raised to minus lambda. So, here for this summation x starts from 2 and for this summation x starts from 1. So, we can say that it is summation x from 2 to infinity, it is lambda raised to power x e raised to minus lambda upon this plus summation x from 1 to infinity lambda raised to power x e raised to power minus lambda upon factorial x minus 1. Now, you can take lambda square common from here to make the power and this factorial same, so that it will be converse to e raised to power lambda. So, this will be, you can say lambda square into e raised to power minus lambda into e raised to power lambda will come, and plus it will be lambda into e raised to power minus lambda into e raised to power lambda will come. So, this will be nothing but lambda square plus lambda. Now, you can find out variance using this expression. So, finally, variance will be lambda square plus lambda minus lambda whole square. So, it is lambda. So, we can say that mean and variance of a random variable following Poisson distribution are same, both are lambda. Now, for which type of problems it is used? Poisson distribution serves as a model for various experiments and phenomena associated with weighting of an occurrence. In queuing theory, we basically use such models. For instance, the number of customers arriving at shop in a given time interval can be modeled using Poisson distribution. So, let us calculate, let us quickly do this example. Now, at a checkout counter, customers arrived at an average of 2 per minute. So, lambda is 2. Okay. Then what is the probability that at most 2 customer will arrive in any given minute? So, at most 2 customer means p is less than p x is less than equal to 2. So, that means p x equal to 0, p x equal to 1 plus p x equal to 2. So, we know that for Poisson distribution it is lambda raised to power x. So, x is 0 into e raised to power minus lambda upon factorial x plus lambda raised to power 1 e raised to power minus lambda upon factorial 1 plus lambda square e raised to power minus lambda upon factorial 2. So, this is now lambda is 2, as given the problem lambda is 2. So, lambda is 2. So, it is e raised to power minus 2 will come here. So, it is 1 plus lambda is 2 plus it is 4 upon 2. So, this is nothing but 5 e raised to power minus 2. So, that is the final answer. That is the final answer for this problem. Now, let us come to Gaussian distribution, which is an important distribution in terms of machine learning. Okay. Because you must have an idea for discrete case also, that how we can find out mean, variance, etc. for discrete distribution, then only I can come to normal distribution or Gaussian distribution, which is an important aspect for machine learning. So, if we follow what is the distribution function for this? So, let us see. A continuous random variable x is said to follow a normal distribution denoted as n mu sigma square. Here mu is mean and sigma square is variance, if its PDF is given by this expression, where sigma is greater than 0 and x is between minus infinity plus infinity, and mu is of course from minus infinity plus infinity. So, its mean is mu and variance is sigma square. Basically here they are basically 2 parameters for this distribution, but they are not only the parameters. Here this mu is nothing but mean, and this sigma is nothing but standard deviation of this distribution. So, how can we say, how can we prove it? So, first for simplification, let us see here the distribution is given by 1 upon under root 1 upon 2 under root this sigma, okay, this e raised to power exponential raised to power minus 1 upon 2 x minus mu upon sigma whole square. Now, let us take a small transformation, let us take z, which is x minus mu upon sigma. Okay. Now, of course, if if this is mu and sigma square, okay, if this n is mu and sigma square, basically if this x is. So, in terms of z, what will be n? So, when this is mu, so this is 0, and when if you find the variance of this, so variance of z will be 1 by sigma square variance of x, and variance of x is sigma square. So, sigma square will cancel out, so it is 1. So, this is called standard normal variate. Basically, we have transformed this into 0 1. Now, so what will be fz? Fz will be 1 upon under root 2 pi e raised to power minus z square upon 2. So, because of this transformation, sigma will cancel out. So, now this is a very simple expression to see the Gaussian distribution, and which is a normal variate with mean 0, standard deviation 1. Now let us try to prove that its mean is 0 and standard deviation is 1. Of course, if mean of this is 0, then mean of if this is 0, then mean of this for this distribution will be mu, and if its variance is 1, then variance of x will be sigma square, that we can simply obtain by using the property of variance or expectation of x. So, now the only thing we have to show that the mean of this distribution is 0 and the variance is 1. So, expectation of x we have to find, so or z we have to find, basically expectation of z here, which is minus infinity plus infinity. This is z into f z d z. This will be minus infinity to plus infinity z 1 upon under root 2 pi e raised to power minus z square upon 2 dz. Okay. It is an odd function, and for odd function it is obviously 0. So, that is clearly one step answer you can obtain that it is 0. Okay. Now you have to compute for variance, you have to compute expectation of z square, that is integral this to this z square 1 upon under root 2 pi e raised to power minus z square upon 2 dz. And now it is an even function, for this it will be 2 times 1 upon under root 2 pi 0 to infinity, it is z square e raised to power minus z square upon 2 dz. Now you can take z as under root 2 times t, suppose. Okay. So, dz will be what? Under root 2 it is 1 by 2 t raised to power minus half into dt. So, that will be under root 2 upon pi integral 0 to infinity z square is 2 t e raised to power, now it is nothing but minus t, okay. And dz is what? Dz is 1 upon under root 2, 1 upon under root t raised to power minus half into dt. So, this will cancel with this 2. So, finally, we are having here is equal to 1 upon under root pi, okay. 1 upon under root pi will come from here, 2 also will go out. So, that will be into 2 integral 0 to infinity, that will be t raised to power half e raised to power minus t finally. And this is nothing but gamma 3 by 2, okay. And that is further equal to 2 upon under root pi, and this is gamma 3 by 2 is 1 by 2 under root pi. So, this is 1. So, variance of x is what? Expectation of x square minus expectation of x whole square. So, that will be 1 minus 0, that is 1. I mean for z, this is z here, okay. So, in this way we can say that for this normal, for this distribution, for this random variable which is following normal distribution, for this mean is mu and variance is sigma square, okay. So, now let us come to one problem based on this, simple problem based on this. The time required to assemble a piece of machinery is a random variable having a normal distribution with mean 12 minutes, that is mu equal to 12, and standard deviation is 2 minutes, that means variance is 4. So, what is given to us? It is given to us that mu is 12 and sigma is 2, okay, 2 minutes. This is also minutes, okay. What is the probability that assembly of piece of machinery of this kind will take anywhere from 11 to 14 minutes? So, what we have to find? We have to find that probability of x when x is between 14 and 11, okay. So, this is nothing but, so for standard normal variate z is x minus mu upon sigma, which is x minus mu is 12 upon sigma is 2. So, when you substitute x as 11, so it is minus 1 by 2 less than equal to z less than, when you put 14, so it is 1, and this is nothing but p when x is less than 1 minus p when it is z. So, it is z, so z less than 1 and this z less than minus half, which is given to us. It is given to us that this value is this and this value is this. So, this is simply difference of these two. So, you can find out a difference. So, it is 0.8413 minus, it is 0.3805. So, this difference is 0.4608. So, this you can, though this is the final answer for this. So, sometimes this is simply for illustration that if a problem of this type is given to you, that then how you can find out, how you can convert that x into a standard normal variate, and then how you can find out the respective probability based on that. So, this distribution, which is last distribution here, Gaussian distribution, or we sometimes call as RBF kernel also in terms of machine learning. So, in this lecture we have seen that if we are having discrete distributions or continuous distribution and we want to find out expectation or variance, and if you want to solve some problem based on simple problem based on that, then how we can do. In the next lecture we will see something about joint distribution functions, their properties, okay, and of course covariance matrix and other properties. Thank you.